With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
According to question, we have to find the potential and electric field at any point R where we have given some conditions, and Q is a point charge kept at the center of non-conducting neutral thick sphere of inner radius and outer radius B, and the dielectric constant is epsilon R. So for given condition of R, we have to find the potential and electric field variation. Okay, so first of all we will find the electric field, and for finding potential we will use relation between potential and electric field, that is V is equal to minus integration E vector dot dr vector. Okay, that is the relation between potential and electric field. Okay, so according to question, that medium has dielectric constant of epsilon r, and the inner radius is a and the outer radius is b. Okay, and a point charge is kept at the center, that is the charge q. Okay, so due to that positive charge, point charge at the center, a charge will induced on inner and outer surface of the sphere. Okay, so let's assume the induced charge, the negative induced charge on inner surface is minus small q. Okay, that is the induced charge on inner surface, that is minus q, and the same charge will be induced on outer surface of the sphere of magnitude plus q. Okay, and the relation of q, the induced charge, induced charge small q will be equal to q1 minus 1 upon epsilon r. Okay, that is the relation of induced charge on inner and outer surface of that sphere. Okay, now for given condition we will find the relation of electric field. So in first condition, if value of r is less than a, so in that condition the point where we have to find the electric field, that is inside the sphere. Okay, so due to point charge q, there is electric field, and electric field due to minus q and q is there is no electric field due to this charge at that point. Okay, so electric field at that point is equal to electric field due to that point charge, and distance is r, so the relation will be equal to k q upon a small r square. Okay, second condition, when r is greater than b. Okay, so in that reason the point where we have to find the electric field will be outside the sphere. So in that condition electric field will be equal to electric field due to point charge due to induced charge minus q and the induced charge plus q. So the net electric field due to minus q and plus q will be 0. So we will get electric field due to only point charge. So we will get kq upon small r square at that point. Okay, that is the electric field for outside point. Okay, now we will find the electric field when r is greater than a and less than b. Okay, means the point where we have to find the electric field will be in that region. Okay, that is the point. Okay, we have to find electric field at that point, and at that point electric field will be equal to electric field due to that positive q charge and due to minus q charge. So electric field at that point is equal to k q upon r square, and the electric field due to minus small q charge is equal to kq upon r square. Okay, so E is equal to kq upon r square minus k upon r square. The value of small q is q, 1 minus 1 upon epsilon r. Okay, so we will get kq upon small r square minus kq small r square plus kq, okay, upon epsilon r small r square. So electric field in that region will be equal to kq upon epsilon r small r square. Okay, that is the values of electric field for these values of r. Now we have to find the potential. So for first case, potential when r is greater than b, okay, that is the radius capital B. So when r is greater than capital B, so we will take a charge from infinity and take any point at distance r. Let's assume that is the point P, and we have to find the potential at that point. That distance is r. So we have taken a charge from infinity and moves towards that point P. Okay, so in that region we have taken an element dr. Okay, and electric field is equal to kq upon r square. So the potential V at that point is equal to minus integration from infinity to that point E vector dot d r vector. Okay, means Vp is equal to minus integration infinity to r k electric field at that region is equal to kq upon r square into dr. Okay, so at that point potential will be equal to kq upon small r. Okay, so for outer point from that sphere the potential will be equal to kq upon small r. Okay, now for second condition, when second condition when that point is when r is less than b and greater than a. Okay, so let's assume that point P is here. Okay, so in that condition the potential, that is the distance r, the potential will be equal to potential from infinity to surface plus surface to that point P. So the potential at that point will be equal to potential from infinity to surface, okay, that is the surface, plus that s to p. So we can say minus s to p e vector dot dr vector. Okay, from infinity to surface the potential is equal to kq upon small r, and for the surface the potential will be equal to kq, the value of r at surface will be b. Okay, because the potential at the surface is equal to kq upon value of r is capital R, sorry, is small b. So kq upon b minus integration, okay, integration from b to distance r, the potential in that region is equal to kq upon epsilon r square dr. Okay, so we will get kq upon b plus kq 1 upon r minus 1 upon b. Okay, that is the potential when r is less than b and greater than a. Okay, now for the reason third, when r is less than equal to a. Okay, that is the inside point. So in inside condition the potential will be equal to, for inside point in diagram Okay, that is the inside point and the distance is r. So the total potential is equal to infinity to surface plus surface to that inner point. Let's assume that point is uh, r, and r to that point p. Okay, so the potential at that point p is equal to potential from infinity to surface plus surface to point r plus r to point p e vector dot dr vector. Okay, so we know the value of potential at the surface, that is equal to k q upon p, plus potential at point r will be equal to k q. One more thing we will get here, epsilon r. Okay, so kq upon epsilon r, the value of r for inner surface is a minus 1 upon b. Okay, minus integration, r means outer surface, that is sorry, inner surface, that is a, to r, electric field k capital Q r square dr. Okay, so the final relation will be equal to kq upon b plus kq upon epsilon r 1 upon a minus 1 upon b plus kq upon small r. Sorry, here we have to put the limit, so minus kq upon r, limit a to small r. Okay, so the final relation will be equal to kq upon b plus kq upon small r, epsilon r, sorry, 1 upon a minus 1 upon b plus kq 1 upon r minus 1 upon a. Okay, so that is the potential at point p when r is less than a.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.